We've all been there. We've got that desktop sitting in the corner of the room collecting dust. It's not quite powerful enough to put in the effort to sell it, but it's just good enough to avoid becoming e-waste. So, what do you do with it? Well, that's what I'm here to help you with. We're going to turn it into a full-fledged home server that will host a network share with redundant storage, run virtual machines, Docker, and even has some networking tricks. So the first thing we need to discuss here is the PC. Now, obviously, not all PCs are created equal, so the one I'm using isn't going to be the same one that you are, and if it is, please leave my house. For this reason, I'm going to try to keep this as general as possible so that everyone with a PC will have this working on pretty much any machine. The only requirement here is that your CPU supports virtualization, and that's it. You can find this out by Googling your processor and checking the product page. Now, it's clear that looking at the PC that I'm using, it's nothing special, and looking at the specs will only confirm that. It's a white box Chinese motherboard with an Intel i5-4590T, 8GB of RAM, a 128GB SSD, and two 8TB hard drives. I added the 8TB drives only because that's the first two that I grabbed off the shelf, but for the purposes of this whole video, you'll want at least 2 drives for the storage, but the more the better. We can see that our CPU does in fact support virtualization, so honestly, we're ready to go. Now for the software, I'm going to do this whole setup twice. One for the folks that are out there starting with a Windows system and want to keep it a Windows system, and another for the folks that are fine with wiping their system and installing something different. Let's start with the Windows. I'll be using Windows 10 for this because Windows 11 is picky about which hardware it'll run on, so I want to make sure that this guide works for everyone. Honestly, these steps are pretty much the same for 10 as they are for 11, so it should be fine. Now for our home server, we want to do 4 things. Hosting a network share, running some virtual machines, deploying some Docker containers, and setting up a VPN. Of course, you can do more or you can do less, but I think this is a good all-in-one starter setup. All right, we're going to start with setting up a network share. What this is going to do is create a storage on this machine that we'll be able to access from other devices in our network. The first step is to set up your storage pool. You'll often hear this referred to as setting up a RAID array. This is just aggregating your physical hard drives in a way to give you more speed, redundancy, or both. In Windows, this is called storage spaces. When setting up a new storage space, you'll give it a name, assign it a drive letter, and most importantly, select what kind of pool you want it to be. You can choose from a few like Simple, which gives you all the space on all of the drives you use, but has no redundancy. This is synonymous with RAID 0 or striping. It's fast, but it's risky since if you lose one drive, you lose everything. Next, we have a mirror or RAID 1. This is exactly what you think. It mirrors everything on both drives. It's not any faster, but it is safer since you do have redundancy. Then you have 3-way mirror, which is the same, but with 3 drives instead of 2. The last one is the most popular, especially if you have 3 or more drives, and this is called parity or RAID 5. What this does is it takes all of the drives you give it and uses one for a parity drive as redundancy. For example, if you give it 5 drives, you'll get 4 drives worth of space with the ability to lose one of them before losing all your data. Since we just have 2 drives, we are going to go with a simple mirror. After that, you'll see your storage space pool show up as you would a regular old drive. From there, we can move on to actually sharing the storage across our network. In Windows, this is actually super simple. Just navigate to the Storage and File Explorer, create a new folder, right-click on the properties, and then click Share. From there, it'll allow you to configure which users have access to this share. For our purposes, we'll be actually creating a new user just for this. You can set this up as a Microsoft account or a regular local account. I went with a local account because. Then going back into our share, we can add our new user to the list of allowed users with read-write access. After that, you're given a share location, which is comprised of the computer name followed by the share name. You can substitute the IP address of the computer for the computer name if you want. Moving over to my other machine, I'll simply navigate to the IP address of my server in File Explorer, enter my credentials, and boom, there's my media share. I can now create files or folders, and those changes will be reflected directly on the server in real time. You can use this for basic file storage or for Windows backups and file history using Windows built-in tools. It really is that easy. You can get more advanced with your storage shaders, including network configs and VLANs to make it more secure, but that's outside the scope of this video. The next thing we want to do is spin up some virtual machines. You could be thinking,
Brett, what do I need virtual machines for?
I don't know, maybe for trying out Linux distros to impress your friends? In reality, there are many reasons to run VMs, but personally I like them since anything running on a VM can be backed up super easily. I don't just mean the data, I mean the entire VM. So like if you have a VM running Linux that's hosting a website and you want to move that to another server, you can just back up that VM and restore it on another system with a few clicks. Yes, that's an oversimplification, but bear with me. So your regular Windows 10 or 11 isn't going to have a way to spin up VMs right out of the box like Windows Server does with Hyper-V, so let's fix that. I'm going to use a software called VirtualBox, which is owned by Oracle.
Oh no, Brett, you're using some big faceless company's software to host your VMs?
Bro, we're on Windows. We have no morals. Jokes aside, VirtualBox is pretty solid for basic VM management. For this example, we'll be running an Ubuntu desktop VM. All we have to do is download the ISO, then create the VM in VirtualBox. Once we give the VM a name and specify the storage, we'll be able to run the install. I used our storage space from the previous step and created a VM folder specifically for this. Once the machine is running, you'll be able to double click it to bring up the GUI. And after installation, you have yourself a functioning VM. There are certain things you can adjust, like adding more virtual disks, as well as creating a shared folder, which basically just passes through a folder from the host to your VM. On Linux, you'll need to install the VirtualBox guest utils for this to work, but after that, you'll see that folder pass through. For networking, you can switch between NAT and Bridge, where Bridge will use the host adapter with no NAT being performed. Basically, use Bridge if you want to easily talk to your VM as if it were a normal PC in your network, as it'll be given an IP address on the same subnet. Then, like I mentioned, we can easily back up our entire VM by using snapshots that can actually roll back the entire VM to a previous state, or we can make an entire clone that can be created and reused on the same host or on a completely separate one. Pretty neat, huh? Okay, next we get to deploy some Docker containers. And if you don't know what Docker is or containers are, I strongly suggest checking out some specific YouTube videos that can go in depth about it. But for the sake of this video, containers are basically apps and Docker is just the platform they run on. Just like virtualization, Docker isn't something you can run right out of the box on Windows, and to go even further, it doesn't even technically run on Windows. There is a workaround for this though with WSL or Windows Subsystem for Linux, which runs a whole ass Linux environment within Windows, and from there we can run Docker. I have a whole video about this if you want to check it out, but I'll just be following the most recent documentation for installing Docker Desktop with WSL too. The first step is to install WSL, and they have made this so easy that it's quite literally a one-line command in PowerShell. After restarting the machine and creating your Linux user account, you have a full Linux environment to play with. We aren't going to go that hard yet, so just close this out and go back to the Docker Desktop installation docs. This is just a basic installation package that we have to download and run. After installation, all you have to do is sign out, then sign back in, and you now have Docker with its own UI. What you do from here is entirely up to you, and if you do some searching online, you'll find that the possibilities to Docker is more than I can possibly show here. For simplicity, I'll show you how to easily spin up a basic container, then I'll do the same thing to set up a whole media server with Plex. First thing is to go into images to search for the one you want. Images are basically installation packages for your containers. We're going to search for Nginx, which is just a simple web server. Then we're going to pull or download the image so that we can run it. Running it will then bring up some optional configs. Depending on what you're doing, you may or may not want to make some changes here. I'm just going to give it a name, then use the port 8085. What this is doing is saying, hey, use port 8085 on our server and translate that to 80, which is what the container wants. The reason you'd want to do this is, say, for example, you run two Nginx containers where both want to use port 80. Well, you can't use port 80 twice on the host, so we can just assign a custom one so that we don't run into any issues down the line. After that, the container should be up and running, and navigating to port 8085 on our host will bring up our Nginx web page. That's it. You're using Docker, go tell your friends. But that's kind of lame, so how about we set up something a bit cooler? In the same way we pulled the Nginx image, how about we pull the Plex image? For config, there are a lot more ports, and these are a bit more obscure than the 80 Nginx uses, so we'll just use the same ones on the host. Another thing we want to do is bind some storage to the container so that the container can see all of our folders with our media. I'm just going to use our media folder on the host and bind that to mount/media in the container. Then we just run it. Plex uses port 32400 internally for its web UI, and since we use the same ports on the host, navigating to that will bring up the initial setup. You can see that when we add a media library, our binding mount is there with our media inside. And a couple clicks later, we have our own Plex server up and running with the ability to watch all of our favorite stuff. Like I said, there are so many possibilities with Docker, so maybe this was useful enough to get those wheels turning. And last but not least, let's set up a VPN so that no matter where we are in the world, we'll be able to get back into our network and access our machine as if we were back in our mom's basement. For this, we are going to use Tailscale. Tailscale is an awesome piece of software that runs on pretty much any machine and uses WireGuard as a backend with some tunneling magic to connect all your devices together no matter where they are. And not only that, it'll also use your machine as an entry point to talk to other devices on your network, so you don't even need to have it installed on every single machine. We are going to start by installing Tailscale client on our server. After this, you'll log into your account. If you don't already have one, pause the video and go make one. It's free. From there, you can check the web console to confirm that you're connected, and you should see all the other machines you have Tailscale installed on. You can see I have this machine and my iPhone. Immediately, this will let each device talk to each other as if they were on the same network using the Tailscale IPs assigned to each machine in the console. And you aren't limited to just these machines though. A Tailscale client can advertise routes on the network, meaning that any subnet that the client has access to can be exposed for all the other Tailscale clients to connect to. To do this in Windows, you'll open PowerShell and run the command tailscale up with the advertised routes parameter being the subnets you want to expose. For this example, I exposed a single device subnet, which is my Proxmox host. Note that you shouldn't ever really expose your server's host UI unless absolutely necessary, but this is just for an example. The IP of that is 10.0.0.73, so after I run that command, you'll see that in the Tailscale console, it'll make me approve that subnet before exposing it, which is a pretty good security feature. After approving that, we can check out Tailscale in action. On my iPhone, I turned off Wi-Fi to simulate being away from my home network. With Tailscale turned on, I can still talk to the machine at my house. Remember that Nginx server we spun up in Docker? Well, let's navigate to that using the Tailscale IP of our server and port 8085, and look at that. And we can do the same thing with Plex. Like I said, it's like being on the same network. And what about that Proxmox server we exposed? Well, let's try to hit that. Boom, easy peasy. Honestly, Tailscale is probably one of my top 5 favorite applications of all time. It's fantastic and makes VPN management and access crazy easy. All right, there you go. Just like that, the old machine you used to watch hours of anime is now a home server. But what if you don't want to use Windows? What if you're ready to take the next step into my nerd layer and run Linux? Well, it's your lucky day. There are plenty of operating systems you can choose to run your home server. Some of the popular ones you'll see in the home labbing community are Proxmox, TrueNAS, Unraid, or XCP-ng. There are plenty more, and each has their own pros and cons, so if you want to do some research beforehand, I strongly suggest that. But if you want to follow me into the darkness, we are going to use TrueNAS, more specifically TrueNAS Scale. The first thing you'll need to do is create a bootable USB drive that you can create by downloading the TrueNAS Scale ISO and using a software like Etcher or Rufus. Then just plug it into your machine and boot from it and install TrueNAS. You're good to go. If you don't know how to do that, just Google it. There are like 4 zillion guides out there. Once you've done that, the output of your system will be a very basic page showing you the IP address, and this is what you use to access your server. Navigating to that IP address from any device in your network will bring up the TrueNAS UI. After logging in using the credentials you created during installation, you're inside your new server. And just like last time, we're going to go ahead and set up a network storage server. Luckily, that's pretty much what TrueNAS was designed to do. First thing we'll do is create a pool, and similar to how we did it in Windows, we'll need to pick a layout. Here we have stripe, mirror, and 3 layers of parity, 1, 2, and 3. Just like before, we'll go with a mirror. Now, TrueNAS is using something called ZFS to handle all the storage backend and file system. This has its pros and cons, but one of the big pros is the extensive levels of caching to speed things up. We're going to skip over all of these for now, but if you're deploying a TrueNAS storage server, that's something you may want to look into. The next step to actually making some shared storage is to create the dataset on the pool that we just created. I give it a name of share since I have the creativity of a stick, and you'll want to use the SMB preset here, which means it's going to automatically spin up an SMB share for us. SMB is Samba, which is the file sharing protocol Windows uses by default, and the cool thing is that it'll work on Mac and Linux as well. Once we've done this, we'll now create the user we want to use to access the share. The only real thing you have to do here is make sure the SMB option at the bottom is selected. Then we can head into shares where we'll see our share, click on the first option to edit the file system ACL, and add the new item to give our user permissions to access it. And that's it. It'll now work just like the one on our Windows server where we can navigate to the IP and the share name and have access to all of that juicy storage. TrueNAS also comes with other data protection measures like snapshots, replication, cloud backups, smart tests, all kinds of stuff. Like I said, it's designed for this. Next, we are going to spin up some VMs, and since this is a server operating system, all of that is built in for us. First thing we're going to do is go into datasets and create a generic datasets for our virtualization. Then we can head into the virtualization tab to create an Ubuntu VM like we did before. We can set the amount of cores we want, how much RAM, specify how much storage we want to give it, and which network interface we want to use. After that, we just start it up and install Ubuntu. The process is essentially the same from there, and after we're done, we have a Linux VM. I will say that virtualization features in TrueNAS are extremely basic compared to even what we saw in VirtualBox. Like, we can clone our VM and we can access the dataset where the VM is, but there's no way to easily export and restore anything. Proxmox definitely has the leg up when it comes to virtualization. All right, time for Docker, and guess what? Yep, it's already built in for us. There's a whole app store where you can pretty much install Docker containers with just a few clicks. You don't have to do it this way though. You can create your own deployment using Docker Compose YAML files. It's hard to really dive too far into this without getting too far into the weeds, so how about we just go ahead and install something. I picked Dashy, which is a self-hosted dashboard app, and the setup just requires you to click install, give it a name, and for a lot of apps, that's it. Most things can be left default. After it's up and running, you can click on the Web UI button, which will automatically launch the app in your browser. And that's it, literally. Of course, we have to do the Plex thing again, so let's do that. We're going to search for Plex, click install, and this time we're going to take a look at the options. You'll see some environment variables for time zone and server token if you want to change those. Then you'll see some storage locations. By default, TrueNAS will create these for you, but we want to specify this. I actually created a Plex folder in my apps dataset to store everything along with my media. You don't have to do it this way, but that's just how I did it. Once you select this for your data and config directories, you're good to go. And just like Dashy, we can click on the Web UI and we'll be brought up to our setup page. From there, it's basically the same as before, except this time our media library is in our data directory. Then it's just a Plex server where we can watch one of the best comedies around, 21 Jump Street. And to wrap it up, we are going to set up a VPN. You may have noticed when I was browsing the App Store before, there was a Tailscale app. And that's how we're going to set it up. Within the Tailscale config, there are two things we want to configure. The first is the auth key, which you can create by navigating to the URL provided. That will essentially remove the need for you to manually authenticate the app. Then there's a spot below for our advertised routes. Just like before, we're going to do our Proxmox IP on the single subnet. To test this, we'll do the same thing on our phone by navigating to the Tailscale IP and the port for our Dashy instance. And what do you know? It works. And the same thing for Plex, and the same thing for our Proxmox host. Neato. Okay, there you go. 2 ways to turn your old machine into a quality home server that'll impress all the nerds in your life. I know I skipped over a ton of stuff, but I feel like this video is long enough and informative enough to get you started. Luckily, I have a ton of dedicated videos on all kinds of home lab stuff, so feel free to check any of those out. If you like this video, then drop a like and subscribe if you want to see more home lab content. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my dusty old PC in the corner of my room that watches me when I'm changing. You guys are the best. And if you're still watching, you're a DDR2. Thank you so much. And I'll see you in the next one.